Alright, let's talk about number families. So in math, we have certain groups of numbers and they have special names. So some of the sets of numbers are counting numbers, whole numbers, integers, and rational numbers. So we're going to talk about each of these number families and how they're related. So let's talk about counting numbers. Okay, counting numbers. So counting numbers are the numbers that we say when we count. So we count 1, 2, 3, 4, and so on. So 1, 2, 3, 4, right? And then the next group of numbers is whole numbers. So whole numbers are counting numbers, but with the number 0, too. So whole numbers are 0, 1, 2, 3, 4, and so on, right? So if we graph this as an inequality, this is 0, we'll do 0, 1, 2, 3, 4, and it would keep going, right? So no whole number is negative. And there aren't any dots. Well, so let me do this. So we would just do, I didn't draw an array because these continue on. So there wouldn't be, it wouldn't include all these numbers in between. It's only the numbers from 0 up that are the tick marks on the number line. So these numbers between aren't whole numbers, they're decimals or fractions or something else, right? But, you know, the numbers go on. They go on and on the number line. So the whole numbers keep increasing. But they start at 0. So the next group of numbers are integers. So integers include all whole numbers, so, and their opposites. So that means if we draw this on the number line, here's 0, 0, 1, 2, 3, 4, 5, and so on, but also their opposites. So negative 1, 2, 3, 4, 5. Okay, so negative 3, negative 2. Or it starts somewhere and goes, you know, here's by 0, you know, and then it goes infinitely, it infinitely decreases and infinitely increases. But so the integers are all whole numbers that are positive and negative. But they don't include, just like for the whole numbers, they don't include all the random numbers in between. So I didn't draw an array. for this one, because if it included all of those, then I would, it would just be a line like this, but it does not include all of those numbers. Okay, so the next group of numbers that we're gonna talk about are the rational numbers. So these numbers are all numbers that can be written as a ratio or a fraction of two integers. So here are some examples. We have a half, 2/3, negative 3/2, -6/1, 0/5, and 4/1. These are all examples. They're all ratios or fractions of integers. So rational numbers include all of the integers because every integer can be written as a ratio or fraction where the denominator is 1. So like this -6/1 is the same as -6, and 4/1 is the same as 4. So rational numbers also include all of the positive and negative mixed numbers because these can be written as fractions. So we can say 2 and 2/3. We can write this as a fraction. We have 8/3, right? So that can also be written as that. So rational numbers include mixed numbers. I'll do mixed number, okay? And sometimes they can be written in decimal form. Just like we know 1/2 is the same as 0.5 or 50%. But they can be repeating numbers like 1/3. 1/3 is 0.3 repeating, right? It's a repeating number. So the decimal will either finish like here, there's nothing after 5, it's 0, or it can repeat like this one. So let me draw a picture that helps you see the relationships between the numbers. Okay, so we're gonna do counting numbers. Counting numbers. 1, 2, 3. And then we'll do whole numbers. Whole numbers, which is those same numbers, so it includes counting numbers, but with 0. None of their opposites. So, I'm drawing a circle around the counting numbers, because whole numbers includes all of these counting numbers. Now this next set of numbers are integers, right? And they're the whole numbers and their opposites. Oh, from in the negatives, infinitely negative number, and it can go up to an infinitely positive number. But because it includes, it's still including the 0, 1, 2, 3. It's so I am circling this because integers also include the whole numbers, which also include this 1, 2, and 3 counting numbers. So, they all kind of go together. If you think of it like a virus, you can say, the virus starts out with these numbers, it starts out eating those numbers, right? But then it expands because it wants more. Then it includes the zeros, which is the whole numbers, and then the virus grows even bigger and it starts including the negatives of the whole numbers too. And so it starts eating all of those numbers. Now we are going to do the rational numbers, which includes all of these things. So the virus is going to start eating even more numbers. So rational numbers can be -3 because you can write that as a fraction of -3/1. And let's do more fractions. -1/2, -1, 0, negative, we can do decimals too, 0.25, 0, 3/4, 3/4 can also be written as 0.75, and 2, it includes all of those, and that goes infinitely negative and infinitely positive. But the virus, it's even more numbers, so it includes all of those other things it already ate. So this is just a picture. If you have a rational number, it can also be an integer, a whole number, a counting number. But if you go from the inside, not all counting numbers are whole numbers, because 0 is not a counting number. Not all whole numbers, right? Not all whole numbers are going to be integers, because, or not all integers are going to be whole numbers, because -3 is not a whole number. It's not positive. It doesn't go, it's not on the positive x-axis or on the positive side of the number line. So it is not, whole numbers are not integers, but integers are also whole numbers. Whole numbers are also counting numbers. All right. So this is just a picture. I don't know if maybe the virus idea helped or not, because it gets bigger. It starts eating all those other numbers. So now we can graph. Now we can do an examples based off of these numbers. So let's say graph integers, I can't spell, less than 2. So integers are all positive or all whole numbers and they're negatives. So let's do number line. Okay, here's 1 and 2. So we include those, right? 1, 2. We're going to include 0 and start doing the negatives. And this just, the numbers go on and on here, but we're not, it's anything less than 2. So we're not going to draw any dots for numbers this way. But the numbers on this side would infinitely decrease, right? So we would include all of these numbers here, going lower and lower on the negative number line. So let's do another one. Let's do true or false. Okay. Let's say all counting numbers are integers. Oops. Numbers are integers. Right. So all counting numbers are integers. Is that true or false? So the integers here, these numbers are counting numbers too. So integers include all of the counting numbers, right? Counting numbers are inside of the virus already. So this is going to be true. Let's do another one. Let's say all rational numbers are whole numbers. Okay. So now we're looking at the whole numbers, which are these, and rational numbers, and all of these. Okay, but this time we're saying all of the numbers on the outside, we're saying all of these numbers are whole numbers. But whole numbers are only counting numbers that include 0. That means negative 0.5, that's not a whole number. It's not a counting number, right? So all of these on the outside include those numbers on the inside, but the ones on the inside can't always be every number that's outside of it. So this is going to be false, you know? All of these can't be whole numbers. This is a whole number. No, this is not a whole number because it's negative. It's an integer. So not all rational numbers can be whole numbers. This is a whole number, and this is a whole number. but all the other rational numbers are not whole numbers. So all rational numbers. So they're not all included as a whole number. So that is number families. Let me know if you have any questions. That's all I have for this.